Hello, good day. I am Neka Grace G. Gatela from Bsed 3A. Today, I'm going to show you my solutions in evaluating integrals using integration by parts and integration by partial fraction. Let's start with integration by parts. The formula for this is integral of u dv is equal to u times v minus the integral of v times du. We have here integral of x raised to 3 ln x dx. The first thing we need to do is to find the value of u, du, dv, and v. Using the mnemonic Liate, we arrived at u equal to ln x, which is a logarithmic function. Then we need to find the derivative of u, which is du is equals to 1 over x dx. And then dv is the remaining from our integral, which is x raised to 3 dx. Then to solve for the value of v, we will just have to integrate dv. So therefore, our value of v is equals to x raised to 4 over 4. And now, we will just have to substitute our values to the formula. So, the integral of x raised to 3 ln x dx is equal to ln x, which is the value of u, times x raised to 4 over 4, which is our value for v, minus the integral of x raised to 4 over 4 times 1 over x dx, which is our du. Then we will just have to simplify it. So ln x times x raised to 4 over 4 is x raised to 4 ln x over 4, then the minus 1 over 4 using the constant multiple rule times the integral of x raised to 3 dx. So, copy x raised to 4 ln x over 4, then minus 1 over 4 times x raised to 4 over 4 plus the arbitrary constant c. Therefore, our final answer is x raised to 4 ln x over 4 minus x raised to 4 over 16 plus c. Let's move forward in evaluating integral using integration by partial fraction. We have here integral of x minus 12 over x squared minus 8x minus 20 dx. First thing we need to do is to factor out the denominator, which is x raised to 2 minus 8x minus 20, and its factors are the quantity of x plus 2 and x minus 10. So now, we can decompose a fraction into a partial fractions. That is simply x minus 12 over x squared minus 8x minus 20 is equal to a over x plus 2 plus b over x minus 10. To simplify this, we will just have to cross multiply it. So, the remaining will be x minus 12 is equal to a times x minus 10 times the quantity of x plus 2 over x plus 2 plus b times the quantity of x minus 10 and x plus 2 over x minus 10. So we have come up with x minus 12 equal to a times the quantity of x minus 10, because we cancel this one. So the remaining is x minus 10. Same with this one, plus b times the quantity of x plus 2 because we cancel x minus 10. Then we just have to simply distribute a. So we have ax minus 10a. Same with this expression. We have plus bx plus 2b. Then arrange the expression and factor out ax plus bx, which wherein we come up with x times a plus b. So now we have the two equations, which are a plus b. Since the variable x is the term, we equal this into 1. And the second equation is negative 10a plus 2b equal to the constant negative 12. So using the first equation, we can have now the temporary value of a, which is a is equal to 1 minus b. Then we will just have to substitute the value of the temporary value of a in our second equation, which is negative 10a plus 2b equals to negative 12. Substitute, we have now negative 10 times the quantity of 1 minus b plus 2b equals to negative 12. So distribute negative 10. We have now negative 10 plus 10b plus 2b equals to negative 12. Simplify. We have now negative 10 plus 12b equals to negative 12. Then transpose negative 10 will become positive 10. Then simplify it. Then divide both sides by 12 in order to find the value of b. So now we have the final value of b, which is b is equals to negative 2 over 12 or negative 1 over 6. Since we have the value of b, we can now solve the value of a using the first equation, which is a plus b is equals to 1. Substitute the value of b, which is negative 1 over 6. And then transpose negative 1 over 6 will become positive 1 over 6. Then simplify. So our value of a is equals to 7 over 6. So now we can express the integral of x minus 12 over x squared minus 8x minus 20 dx equals to integral of a over x plus 2 minus b over x minus 10 dx. Then integral both fractions and we come up with these integrals. So substitute the value of a and b, which is the value of a is 7 over 6 and the value of b is 1 over 6. Then using the constant multiple rule, So now we have our final answer, which is 7 over 6 ln of the abstract value of x plus 2 minus 1 over 6 ln of the abstract value of x minus 10 plus the arbitrary constant c.